All right. Today we are having an introduction to Python and testing, test-driven development with PyTest. So we are going to learn all about the Python programming language. It's known for having a really nice, elegant syntax and being a pretty friendly language to learn. It's used by a lot of universities to teach programming, and for good reason. And it's used a ton in industry. It was used a ton by scientists, and there were all these sort of scientific computing libraries and in Python, and that's a big part of why Python is also now used a ton for data science and machine learning. Um, we're going to do a pretty deep dive into the Python language and see all sorts of features. We'll also see how to use the PyTest testing framework for writing unit tests in a test-driven development style like we saw in the JavaScript lesson. Um, this lesson will really be broken into three parts. We'll have intro to Python, which will sort of have a part one and a part two, and then looking at testing in Python, we'll get into some slightly more advanced things as well. We'll be learning about syntax, more complex data structures like lists and tuples and dictionaries, some built-in methods, manipulating lists and dictionaries. We'll look a little bit at error handling, which will be new. We did not talk about that a lot in the JavaScript lesson, and a little bit of file manipulation in Python and pathing, which will also be new. We'll look at test-driven development, and we'll see some more advanced stuff with testing, including how to fake user input using a technique called monkey patching, which is really cool. So that's what we're going to be covering today. And before we get too deep into this, I do want to briefly share from the Python enhancement proposals, or PEP, which is basically the sort of collective Python organization that defines what the language is. Um, every programming language tends to have its own philosophy because it's all about how do you model the world. The same way when we're solving a coding problem, we have to make different kind of algorithm or design choices. Sort of how do we simulate the world to solve the problem? If you're designing a programming language, it's the same thing. And the creator of Python, benevolently called the Benevolent Dictator for Life, wrote down some guiding principles that kind of say how Python is designed and are good guides in terms of how to use it, right? That beautiful is better than ugly. It's better to be explicit than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special characters aren't special enough to break the rules, although practicality beats purity. Errors should never pass silently. We want errors to be really noisy so we know what's going on. Unless, as the programmer, we've explicitly told our program to silence the error. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it. Although it might not be obvious at first, now is better than never. Sometimes you might need to punt on something. If the implementation is hard to explain, if it's hard to explain my code, it's a bad idea. If it's easy to explain my code, it might be a good idea. And lots of namespaces, right? So this is a little abstract, and there's in fact a whole conversation in the Python user group on this, right? If anyone's interested, they can look. And I just wanted to share this as sort of an introduction to the broader programming community. And especially these first principles here are good programming principles just in general, but also as you write more Python code, you'll sort of see that the language is designed to help us write code in this fashion. So let's go ahead and dive on in here and get started. And I've got up here a print statement, and we're just going to say hello world, which is always the classic way to run a program, our first program. And let's go ahead and run it. And we've got hello world. Now, instead of hello world, maybe we want to print our name. I can declare a string variable really simply in Python. I don't need let or const or anything at the beginning of the variable in Python. I just can declare the variable, and whatever is here on the right side of the equal sign gets assigned to the left. Note that while in JavaScript, the convention would be camel case, in Python, the convention is for naming variables is snake case, which means all lowercase with underscores between the words, as opposed to camel case, where like the hump of a camel, you have an uppercase letter starting each word. So all of your variables in Python should follow the snake case naming convention. And this is actually a really big deal in programming for consistency. And on the job, if you're not following the convention for the language, you'll hear about it right away. And I can go ahead and I can print my name and we can run that code. And let me just save my file so that the change is there. Now that white dot has gone away and it tells me there are no unsaved changes in my file and we see my name printed. And just like we could in JavaScript with string interpolation, we can do string interpolation in Python. It's called an F string. Because it starts with the letter F, probably for formatting. And let's just say hello, and then in curly brackets, we put the variable name. And we get some nice autocomplete help here from VS Code. And then down here at the bottom of the terminal, we can see that we're printed out our F string. And we can already see that Python syntax, it's really clean, it's really friendly. It's pretty simple to use. So in a lot of ways, this is why it makes a great learning language. We can do a lot more with strings. And in fact, let's start talking about doc strings, which is how you do multiple line comments in Python. You use 3 double quotes. And in fact, if I want to have a formatted string, I would use that same doc string. So maybe I want to print something to the screen in a certain way. Let's go ahead and print our formatted string. And we see here really easily, I'm able to add all sorts of formatting. So if you're working on, say, a command line program and you need to print output in a more sort of organized or structured fashion with multiple lines, a formatted string like this using this doc string approach is probably the way to go. And let me just go ahead and comment out my print statements. You can also use the new line character. And if I've got single quotes going on, I can use the / to escape special characters. And /n is the special new line character. It's like hitting enter on the keyboard. So with fingers crossed, we should see this printed out on 2 lines. And indeed we do. As you can see though, this can get a little clunky. So again, the formatted string really is the way to go if we need to get fancy with stuff. And again, with string interpolation, I can put any code I want inside those curly brackets, right? And it'll run. just fine. So now that we've talked about the string data type a little bit in Python, let's talk about numbers. And Python actually has a couple different data types for numbers. It does have an integer data type and it does have a float data type. And actually, let's look at the type of our string before we go too much further into this. And let's use the type function that's built into Python to look at the type of my name, which is the string variable that we created just a couple minutes ago. And we see something really interesting here. We see these brackets and then it says class string. So everything in Python is an instance of a class. We'll learn more about that later, but basically it means everything in Python is an object. As we'll learn, Python objects are a bit different from JavaScript objects. They have a little bit more going on. So when you look at the type of variables in Python, this is what it'll look like. And we see here, this belongs to class string. So this is the part that we want to look at to see that this is a string. Right? And let's do this for numbers as well. And let me just comment this out. And let's make a number and let's print the type of this number. And we see this is class integer. So Python is also a dynamic language like JavaScript. I don't have to explicitly declare that this is an integer. Python will infer that for me, but it does have different types of numbers. And a floating point number, which is how computers represent decimal numbers, like say 3.14159, which is the first couple values of pi, we'll see that this has a different type. And indeed, we see that this is class float, right? So we don't have to directly worry about this too much, but it is good to know, especially it's a reasonable thing that might be asked in an interview that Python has different data types for numbers. You can manipulate numbers all the ways that you would expect. Right? We can add 3 to the small number. Something that's useful to know is the modulo operator, which I don't think we talked about, which is where maybe I have a number like 25 and I want to see how many times 7 goes into this. You would call this 25 modulo 7. And let's run this and see what it says. And well, actually, my apologies. What we're getting here is the remainder of 25 after it's been divided by 7, right? So 25 modulo 7 equals 4. 7 goes into 25, 3 times, that gives us 21. And what's left over is 4. So for example, 28 modulo 7, since 7 goes evenly into 28 4 times, that's going to give us 0. There's a bunch of other number operators that we've seen some of. I don't want to go through all of them right now, but modulo is good to see. And this probably will come up later in the course. So just like JavaScript in every programming language, we also have Booleans. And we just use true and false, but in Python, we need to use a capital T. So we can see here, we've got, is it sunny? And why don't we do, is it rainy? And we'll see Boolean conditional logic later. But it's sort of a lot of the same fundamentals you see in other programming languages like JavaScript. I think this is the main difference, right? We just have to capitalize the first and last letter. We do have to deal with a little bit of truthiness in Python, but it's not as bad as JavaScript. And let's look at a couple comparisons. So let's just do true equals hello. And we see that unlike JavaScript, Python is not trying to make hello be truthy for a comparison. Though it does do that in if statements, which we'll see later. And we can just use the double equals in Python. You can also do the is comparison operator, I believe. And let's see if I have this right. Right. And so this is a very nice way to do comparisons is instead of double equals, I can use is, and it makes it a bit more readable. I can also do is not. Right. And is it sunny is true. So this is not operator gives us false. Right. And the other way to do that would be true is not equal to is it sunny? Try to prefer is and is not because they are more readable. So that is considered a bit more Pythonic, which is what people like to call it, like we sort of saw with those Zen of Python examples. So let's take a look at lists, and then I think we'll take a short break maybe. So we've covered a lot of the fundamentals. Lists are where things start to get more interesting and where Python also starts to get more awesome. So a list in Python is a series of iterable items. What does, oh, excuse me, let me exit this. What does iterable mean? We can loop, aka iterate through it. And lots of things in Python are iterable. In JavaScript too, but Python has like a much more complex idea of iterable, and we're going to see lots of different ways of iterating and looping through things that aren't just like arrays or lists. A JavaScript array is really much more like a Python list. So lists can be iterated, looped through from left to right. And the order of items in a list is preserved. So those, I think, are kind of the key points of lists. And as we'll see, Python offers a lot of flexibility and power when it comes to lists. I can put anything I want in lists. For this example, I'm just going to put some strings in here, and we're going to make some different kinds of berries, like maybe a grape, a tomato. I think a cucumber is technically a berry. I don't know if an eggplant is, but we're going to just go a little wild here. And I feel like we definitely need a blueberry. So let's look at the type of our list. And again, we'll see it's a class of the instance list. And let's see here. I moved into the wrong directory by mistake. So the file I'm running, main py, is here in this part1 directory. And at some point I shifted out of there in the command line. That's what that error was. And just to demonstrate really quick, as long as we're talking about the command line, just like with Node.js, where I can run that read, evaluate, print loop for JavaScript, if I just type Python on the command line, it gives me an interactive little Python coding environment. And if I want to quit it, I can type exit. And so again, I really recommend having one of these open in a second shell session whenever you're writing code, because it's a really nice way to run little experiments. And by the way, if you right click inside the terminal, there's a clear option that will clear it for you, which is quite nice. And now I should be where I want to be and run my code. And we see berries as a list, which is not too surprising. Let's interact with our list a little bit. So to grab an element from the list, we use the square brackets, very similar to JavaScript. And we see here that lists are 0 indexed in Python. Berries sub1 did not give me grape. It gave me tomato, right? We call grape the 0th item in the list. Tomato is the first item in the list. Cucumber is the second item in the list, and so on. If I want to go backwards in my list, I can use a negative number. And this is super handy. And we see that this is a little different, right? -1 gave me the last item in the list. So it's sort of like if this is 0, 1 goes to here. And if we go from -1, it goes from 0 backwards to the last thing, I think is the way to think about it, right? So it's sort of like, let's see if I can, I probably can't draw this. I was going to sort of draw like a loop, but I'm not sure that's quite the right illustration. But again, -1 will give us the last item in the list. And so, -2 will give us the second to last item in the list. So we'll see banana here. And just to build on this, if we want to grab a part of a list, which is called slicing, Python makes that really easy to do. We didn't really get into slicing with JavaScript. It does have a slice function for arrays, so you can do the same thing. But as we're about to see, Python makes it really, really easy. So let's grab a slice from the middle and see what this does for us. So note that what happens is we got cucumber and eggplant. Right? And if we just kind of write down our indices, we can see what happened is that this slice said grab the value, the item at index 2, right? So this is called inclusive because sometimes in other programming languages or for other methods in Python, if we start at index 2, it doesn't include it. It might start at 3. That would be called exclusive and go to index 4. And in fact, we see that index 4 indeed is exclusive, right? We did not get watermelon. We got cucumber and eggplant. So the starting value here is inclusive, and we go all the way up to, but not including index 4. Right? We're excluding index 4. So that can be a little bit of a gotcha. That's also why having the Python open in the REPL to test this real quick is kind of your best friend, because maybe, I can never remember this. And so I want to do something like this real quick to help me remember. And I'm going to use this sort of bracket notation, and we'll just say like 1, 3. And right, I didn't even need to assign this to a variable. I created the list and applied this slicing operation to it directly. And we see that it starts here at index 1 and includes it. It goes to index 2, which is C, but it doesn't grab index 3. So a lot of the times when I'm programming, I can't remember this off the top of my head, and I'll use the Python REPL like this just to double check. So let's just do a little more slicing because there's a couple useful things here to see. And let's bring this up, and I think I'll just go ahead and clear this. We can start from the very beginning and go to a certain index. Right? So this slices from the beginning, inclusive to index 3, exclusive. It's grabbing the 0th item, the first item, and the second item, right? It grabs grapes, it grabs tomatoes, and it grabs cucumber. And so we can just have the colon there by itself. If I want to start maybe partway through and go to the end, I could do something like this. Just 2 and a colon. And this is going to start at index 2 and go all the way to the end. All right, and we see again, this is inclusive, index 0, index 1, index 2. We grab cucumber and we just go all the way to the end because we have an open colon there. So there's one more slicing thing I do want to show, and then we will keep on rolling. This one is really useful. Let's just add a couple things here for emphasis. This one is reversing. if I put 2 colons and a -1 at the end, this should reverse my list. And indeed, we see, because basically we're saying start at index -1 and go to the beginning. And that, I think, is the logic behind why this is a reversing operation, right? We're starting at index -1, and then we're going backwards and grabbing everything. And so we can reverse a list real fast like this. This will definitely come up in all sorts of code wars and leak code problems. Now I'm curious to try this with a string and see what happens. And indeed, just like in JavaScript, we can interact with the string kind of like it's a list. It's not a list class, right? That's not its type. But under the hood, Python is using a list or something like a list to store each individual character, right? And so I can use this we can interact with strings like lists and reverse them. And similarly, if I wanted to grab the first character in a string, I could use list indexing to grab the first character or any character I want. I think this is actually a good point to pause. Let's pause, and I'm curious what questions folks have or what's on people's minds. Rick, yes, sir.
Yeah, I just tested it, so I know the answer, but before you were saying like is not is also equal to the exclamation point and equal. So Python, you can use either, you can use is not, or you can use exclamation point equal. Personally, I like the exclamation point equal instead of is not.
Yeah, there's your mic is cutting out by the way.
Oh,
But yeah, there's a lot of Python's very flexible with its operators, and I think its syntax is a lot friendlier than JavaScript for sure. Sam, yes, sir.
Yeah, Python like JavaScript, where all the primitive data types are passed by value, and then the complex ones are passed by reference.
Yes, I want to say yes. Some of the primitive ones are a bit less primitive, but yeah, in essence, yes. Like, and in fact, why don't we just test this out right now real quick? We haven't quite gotten to functions, but this shouldn't be we can write a simple one, right? We'll just write like modify string and we'll pass in some string. And when we write a function in Python, as you guys can see, we use this def keyword instead of function. We use a colon at the end, and we do have to indent. If I do this, this is not in the function. And in fact, Python is unhappy here because there's nothing in this function. I would have to type pass here, and pass is sort of an empty placeholder. But let's go ahead and let's do some string equals let's do this to modify it. And so why don't we modify our message string, and now let's print our message string, and we should print it here too. And I'm actually not 100% what happens, so this is good to see, I think. So we see indeed the message string is unmodified. And just for fun, let's go ahead and print in here to make sure that indeed we, weren't screwing up our logic somehow. And we see that the logic is good, right? So I'm pretty sure that yes, primitives are passed by value. If we were to do this with a list, in fact, let's just do that right now. Let's just have a list of one thing, and let's make a method modify list. And we can do fruits dot append. And this should be my list dot append. And let's print an F string, and we'll say updated list is my list. And let's print out fruits here. And let's print it out here and see what happens. And I have to save my program. And so this one, oh, it would help if I ran this modify list method. Note that we didn't see this updated list print statement. I let my brain get a bit ahead of my fingers in terms of coding. And so here we see indeed the list is passed by reference, right? And the list has been modified because it starts out here with Apple. We pass it in as an argument to this function. We add something to it. We see the updated list. This my list variable that's created in the function, but more importantly, here, this fruits list outside the function scope is modified as well, right? Because just like with JavaScript, we have function scope, and then we have global scope. So indeed, it was not this value that was passed in, but the reference to where that list lives in memory that was passed in there. Yeah, great question. Was there another Tom? Yes, sir. And then I do want us to take a break.
I don't know if this could also hammer home a point, but I know that like if you take a list and you run a reverse and you try to assign a if you splice it in reverse, so if you use -1 as step and try to assign it to another variable, if you try to change that reversed list, it will still modify that first one, at least from what I've experienced before. So how would you go about creating a copy of it and still being able to modify like a reversed version of it?
I think I would need to code up an example
Gotcha.
to
Okay.
track that. Yeah, totally. All right, guys, thank you. Let's take 5, and when we come back, we are going to look at tuples, which are very similar to, but slightly different from lists. Thank you guys, and I'll see everyone in 5 minutes. All right. So we left off with there was a really good question around is Python like JavaScript in terms of how it handles pass by reference and pass by value? And right, I was pretty sure, but the best source of truth is always running code. And so we ran a little experiment, and indeed, primitive values like strings are passed by value, but complex data types like lists are passed by reference, right? Where if I'm passing a list into a function as an argument, it's not this value right here. It's the reference or the pointer to where this list lives in computer memory. So then in here, fruits actually gets modified. So speaking of lists and modifying lists, Python has something called tuples, which is really similar to a list. And, with the list, I can have stuff in it, right? I can have true, I can have none. None, by the way, is the Python version of null in JavaScript. So this represents an empty value. I can have hello. And, we can print our list out. And I can modify my list. Like maybe I decide I don't want that true value there. Maybe I want it to say a message instead. So let's change the second element in that list to equal something important. And let's print out our list. And we'll see that our list has modified. And this is pretty intuitive, right? This is what we expect with lists. This is what we expect with JavaScript arrays. Sometimes, though, we don't want to modify the stuff in the list. We might have, for example, days of the week, and it's always going to be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And when I want to have something very similar to a list, but I don't want it to change, right? I don't want to accidentally mess up my own code. There's this idea called defensive programming, which is basically saying, to err is human. So all programmers make errors. So write the code in a way that makes it hard to break. Well, that's what a tuple is for. And a tuple uses parentheses to define it instead of the square brackets of a list. And it's just like a list in that we have items in an order and we can iterate through them and use all of the cool list slicing operations. And let me get my mouse back here in VS Code. But we cannot change the tuple. And let's print out our tuple. Let's look at the type of our tuple. Let's look at, maybe the sixth day of the week, if I can get my indexing right. I believe that's going to be 5. I think that'll print out Saturday with any luck. And let's run this. It's always a good idea to run your code. I run my code like every 2 lines of code that I write. If I go more than 5 minutes without running my code, I get nervous because it's always the programmer errors we don't realize we're making that creep up on us. Now, let's try to change one of these values. And let's say days of week sub 5. Let's change it from sat for Saturday to cat for, Catterday. And let's go ahead and let's print out our tuple. And when we run this, we're going to see that Python is not happy about this. And in fact, we get an error, right? And we get actually a really useful error, though it's a bit verbose. It tells us the tuple object, right? We have an object here that's an instance of the tuple class, does not support item assignment. So I can loop through it, I can slice it, I can dice it, but I can't modify it. So use a tuple when you have data that you're not going to change. It's a little more memory efficient. Otherwise, use a list. When in doubt, just start with the list and you can always change it to a tuple later. So that's the tuple type. There are a couple other types like sets in Python that are useful, but those are a little out of scope for today. And a good 90% of the code you write will involve lists and dictionaries, which we're about to see with the occasional tuple. So dictionaries are quite cool. They're very similar to objects in JavaScript. And in fact, when we define one, it will look pretty similar. We use those same curly brackets. There's keys and values, but the key has to be in quotes. In JavaScript, if I was making an object, I could do this. As you can tell by the red squiggly there, Python does not like that. your key values in your dictionary, right? The key here is make, the value is Ford, have to be wrapped in quotes. You can use single quotes. I'm just kind of using double quotes out of habit. It doesn't make a huge difference. The values can be anything, right? It can be a number. Let's add some mileage to this car. It's got a lot of miles. And let's maybe add, some car features. Let's have that be a list, and it's going to have heated seats, and it's going to have Bluetooth, and it's going to have GPS. Right, and this is my car dictionary. And if we print it out, we'll see what it looks like. Let's go ahead. Let's look at its type as well, as long as we're doing this. And then we'll see how to grab individual keys and values and mess with them. And I forgot to comment out this line of code. And let's add a note here, throws an error because we can't modify a tuple. Comment it out. So now my code should run and we can look at our dictionary. And we see our dictionary printed out pretty nicely. You can not only nest lists, you can nest dictionaries. So you could have a dictionary inside a dictionary. For example, maybe the features, maybe we want it to look like this. If we wanted to organize our data in a different way, right? So two different ways of organizing the same data. And let's see how we can interact with the different keys here on the dictionary. So the easiest way is with square brackets. And you can see here that VS Code actually is giving me a really helpful list of all of the different attributes on the car. And as you can see, I have to include them as a string in quotes. And that'll give me the car's mileage. What happens if I have a non-existent key? Well, let's try print my car foobar, which is the classic programmer term from the military term FUBAR that kind of migrated into the programmer world. So if you see foo and bar as sort of like example placeholder values, that's where it comes from. And we see a really interesting error here. And our error says key error foobar, and we get the line of the code. And what this error is telling us is that this key does not exist, right? And that's the problem. So sometimes, we might not know if a key exists or not. Like maybe there's optional values here in our dictionary. So Python has a method called .get for a dictionary. And let's watch what happens when we run this. And note that this does not throw an error and it returns none. So .get safely handles non-existent keys. And we can even specify a default value. We can tell it, hey, if this key doesn't exist, return something. In this case, we'll just return a string message. Alex, yes, sir.
Can you use the dot get method for values as well?
No, you have to give it a key. And that's how you would get a value. Does that help answer your question?
Sure does.
Yeah, good question. We will see in just a little bit when we get to looping. There's a lot of ways to loop through both keys and values in dictionaries, though, as to your question. So there are some ways to manipulate that and get there and play around with that stuff. Let's talk a little bit about functions in JavaScript, and then we will, or excuse me, in Python, and then we will come back to working with dictionaries, and it will pop up when we get into looping, because we'll see there's lots of ways to manipulate and work with these. The main thing is start with the square brackets. As your code starts to get more advanced, you'll sort of see situations where you realize, hey, I might not know if this key exists, so I'm going to use .get. So it's good to know about .get. All right. Let's talk about functions. So there's a couple things to know with functions. The big one is sort of related to a core feature of the Python language. You create a function by using the def keyword, which is short for define, I believe. You need a semicolon at the end. These parentheses here are where we put arguments, which we'll talk about in a second. And then you don't need curly brackets or anything. But any code that lives inside this function does need to be indented. As you'll have noticed, we don't need semicolons at the end of lines or anything like we do in JavaScript. So I can then execute my function. And when we do this, this will work just fine, but we're about to see a wrinkle. And the wrinkle is this. In JavaScript, JavaScript doesn't care about indentation or white space. It's not meaningful to the programming language. It's not part of its grammar. It's really just there for us, the programmer. Python does. And we see this big red squiggly right here that is already giving us a clue that there's a problem. Right now, that print statement is not inside that give me 5 function. And in fact, we're seeing this indentation error that Python expected an indented block after the function definition here on line 171. So if you ever want to write sort of a skeleton function that you're not ready to put code in, Python has a special keyword called pass. And it is basically an empty placeholder. And so now this is an empty function, but 5 is still not inside of it because it's not indented. And if we run our code, the error will go away. We see 5 printed out. Let's also talk about what an empty function returns. Both Python and JavaScript have a default return value of none, basically. Python does not have undefined the way JavaScript does. I don't believe it just has none. And here we see, even though I don't have a return statement, by default, this function returned none. And that's true even if I did this. Right, we see it still returns none. Now, if I do something interesting here, let's see what our return value is. Oh, excuse me, I think I got myself confused. I think I was expecting this to return X, but we do indeed need a return statement there. Right, and now our function is actually returning a value. So that's sort of the basics of functions. Let's flesh this out a bit. let's go ahead and let's add some items together. And this is going to be really simple. Let's just maybe have a print statement and we'll say, you know, add A plus B and it equals, and let's just do it. And let's also return that value. And now we can run our add two items function and let's add, oh, I don't know, 4 and 12. And we get 16. Right? So far, so good. What though if we want to, well, let's talk about adding multiple items later. There's some more complexities that we can throw in here. But I also want to talk about let's talk about named function arguments. So let me put together another function here to demonstrate this. Let's say we want a function that is a greeter, like we've seen before, and it's going to take a name and a message, and it's going to return a greeting message that says, you know, hello person. And then it's going to say the message. So this is great as far as it goes. Right? I can run this and we'll see, hello, Alice, it's sunny. But what if I have lots of different greetings and lots of different messages and I'm tired of typing in the message all the time and I want some sort of default message? Well, I can use what's called a named argument and I can give it a default value. And let's watch what happens when I run my greeter method now. So actually that works out okay, but let's run it like this. And let's just pass in Alice, or actually let's pass in Bob. And we see here that it uses this default value for the argument. Now that we have named arguments, we might want to add some more. And maybe when I'm greeting Carol, I want to say the weather is rainy. And my message is grab an umbrella. And what I want to point out here that's important is note that the order of how I define these arguments is name, message, and then weather. But when I'm calling it here on line 190, I have to start with name. So these are called, it's confusing because we have the name variable, and then these are called named arguments. When you see this parameter and an equal sign and a default value, this is a named argument in Python. You have to have your plain old arguments first, followed by the named ones when you define the function. But then when you call the function, you have to have your plain old arguments here, but the order doesn't matter, right? Because I'm using these names now. So here it's message and weather, but here it's weather and message, and I can do whatever I want. The other thing that is relevant to all of this with functions in Python is, unlike JavaScript, where you don't have to pass values, in Python, for these unnamed arguments, you have to pass a value. and we see this error, greeter is missing one required positional argument, name. Right, so once I define a function, unless I'm using a named argument like this and giving it a default value, I have to pass values or otherwise it would throw an error. In JavaScript with add two items, if I don't pass an A and B, we will get back undefined or none or something, but it'll run. In Python, it'll throw an error and say, hey, you said this function has to take two arguments. They gotta be there. Tom, yes, sir.
Are they able to take in multiple defaults for the same one?
No,
Okay.
yeah. Chris, yes, sir.
Yeah, isn't there a way to like maybe you can null out one of the well, not null. I forgot I thought there was a way to like you had those three arguments, name, message, and weather. But is there a way to set those to where if you only provided message, weather would still kick out?
Where this would maybe be an empty string or none.
Yeah, something like that. I guess.
I think I understand what you're saying. So I think the answer to your question is we would change the default value, right? Here, it just prints an empty string. We could also just do whether equals none, in which case it prints out nothing. Is that what you were wondering about?
Yeah.
Yeah, totally. And just like we saw here with Bob, right? All I'm passing is the name for this positional argument that has no default value. And then we'll use these default values for the named arguments. And that's okay, right? Python likes that. Now it gets a little tricky, right? In terms of if you're constructing a string. And in fact, because it's printing the string value of none, which isn't what we want. But that's more of an implementation detail, right? So in this case, it might make more sense to have it be an empty string. And maybe, we don't want this period here. Does that help answer your question? Awesome. Yeah, great question. Great question. All right, we have a couple more things to throw into the mix here with functions, and then we'll take a break. So there's a couple more advanced behaviors we can do. There's something called star args in Python. And what this does is it lets us pass as many arguments as we want. And let's take a look at what this is, and then we'll see how to use it. Oh, excuse me. Because remember in Python, like if I have to pass a value for every argument, right? Unless it's named. So if I want like a random number of things, how do I do that? And the answer to that is star args, right? If I have, I don't know, some unknown amount of people. So we'll run this and we'll see, first of all, it doesn't throw an error. We'll see what type of thing args is, and then we'll see how to grab this data. So note that Python is doing some work for us here. I use this special star keyword and then args, but under the hood, Python has created a tuple named args. And every single argument or parameter here has gone into that tuple. So think about a command line program where, we might say like ls-a-f-g. You can have a lot of flags to it. if we're writing the ls function, how many arguments does it take to figure out what the command is? It could take 1, it could take 2, it could take 3. We don't know how many the user is going to pass in, right? And so this is the kind of situation that star args is meant to solve. And if we go ahead and we just print out that tuple, we'll see that every single one of these arguments is in there. So star args is how you can pass an unlimited amount of arguments and how you can pass a different number of arguments to a function, right? Because otherwise this would break in Python. Tom, yes, sir.
Since tuple's immutable, would you have to do a data conversion, a data type conversion inside of the function if you wanted to be able to manipulate the actual input itself?
That's a great question. Not necessarily. I might do something like this. And now I've assigned the value from that tuple to here, right? And so maybe now I want to do like, now I can modify this variable. You know what, let's do something like this. And this is because we're passing by value for primitives, right? So when I do this, I copy Carol into this variable, and now I can just modify it and work with it. Yeah, great question. So there is another variation on star args called star star quargs, which is even fancier. And this is unlimited keyword arguments. So keyword arguments are the same thing as a named argument that we saw earlier. So for example, if I wanted to write a function maybe called who am I? And I want to pass in not just like values, but named arguments that have some extra information, I would use this star star keyword argument. We'll fill this out in just a sec. Let me show you how I would call it, because I think that will help explain things a lot. So here I have a bunch of keyword arguments or named arguments. And maybe we're going to do this twice. And let's get rid of Alice's age just to show we can have different things here. And we're going to, let's go ahead, let's print out the keyword arguments. Let's print out what type it is. And while this is looking ahead a little bit, we are going to do just a little bit of looping. We're going to say for keyword, let's just say for item, or let's just say for keyword argument in quargs, and we'll do print with an F string, and we'll say my key is keyword argument. Let me make sure I get this right here, folks. One moment. Oh, yeah. So keyword args is really a dictionary. So this is getting a little ahead. We're looping through keys in a dictionary, and we'll see this in a bit. But I did want to demonstrate this. And it looks like in my code, I forgot to wrap this in curly brackets. Because if we look here, we see it's printing out the string keyword args key and not this. It's not interpreting this as Python code. So let's go ahead and fix this. And let me clear the console and we'll run this code again. All right. So what just happened here? First off, we see that this star quargs, again, is a special placeholder, right? The 2 stars tell Python that this is special. And it lets me pass in as many named arguments as I want. And I could put in all sorts of random stuff. And under the hood, Python creates a dictionary to hold these things, which is probably how it works when we make named arguments. And we see that there's a dictionary object here. And when we print it out, we see that the key is the name or the key of our keyword argument. And then the value is the value, right? We have name Dan, age 20, job skydiving instructor. And we see those were the arguments that we passed in. Name Dan, age 20, job skydiving instructor. And I'm able to mix it up because with Alice, it's different. And then when we loop through those keys, we can see each key in the dictionary and we can grab each value. So again, say for command line input or user input, star quargs is super powerful. Now, I do want to issue a word of warning here. If we go back to the Zen of Python, the second principle here is explicit is better than implicit, right? Saying exactly how something should be is better than having it sort of be unclear and implied. And the problem with star quargs and star args is it's not explicit and it's implied, right? And so what if in my code I have something really important, like if you know, quarg's age is greater than 20, print this person is more than 20 18 years old, and let's change this to 18 so it works for Dan. Now the problem here is we're passing an age for Dan, but we're not for Alice. And we get an error, right? And while there's ways to make that error go away, the point is if I, as a programmer, am trying to use this function, I can't just look at the arguments specified here in the definition to figure out what I need. I have to dig into the code. And while for a simple example like this, that doesn't seem like such a big deal, as code bases get bigger, this can become a nightmare because it can become really, really hard to tell what arguments are important and required versus which ones aren't. So this is not explicit, right? This is not explicit. So there are certain situations like command line input, maybe where you need to use these, but unless you need to use it, avoid it. Do not use it unless you have to. So I just want to say that again, because people get really excited because it's really powerful, but it's like with great power comes great responsibility, and your code, I promise, will become a big spaghetti mess if you use quargs and args all the time. Only use them when you need them. Arnold, yes, sir.
Yeah, I just noticed that for quarks, for your for loop, so you don't need to put like dot items for regular whenever you loop dictionaries.
Say that again.
So you know how when you loop dictionaries, you have to put like let's say 4 keys in quarks dot items. Do you need to do that in quarks?
You do not need to do that to loop through the keys of a Python dictionary. I'd have to check if that's specific to Quargs or in general with Python dictionaries. There's a couple different ways to do it. So we'll kind of cover that a bit more in depth in a bit. Yeah, thank you. Tom, yes, sir. And then I think we need to take a break.
Are you able to set default values with these like quargs and args statements?
No, you are not.
Okay.
Yeah. All right. I do see a couple more questions. Let's go ahead and take a break though. We've been running for a while and I'm happy to take some questions during the break. So when we pick back up, we've dived pretty deep into functions. After that, we'll look a little bit at if else statements and conditional flow, and then we'll get into looping, where we'll get into the different ways of looping through dictionaries. I think your question about using dict items is addressed here. In part, it's just, you know, my brain gets filled up really quick. So let's take a break, and then when we come back, we'll look at conditional flow and looping. Thank you very much, folks, and we'll see you all in a little bit. All right, so we covered a lot of ground. We were looking at star quargs and star args. And again, to kind of go back to the fundamentals, the main thing to know is that you can have these positional arguments, and then you can have what are called keyword arguments or named arguments, where you can provide a default value. And the nice thing about that, again, is it gives you some flexibility where I can call a function. I have to specify this positional argument or it'll throw an error. But for these keyword arguments, it'll use the default value and not throw an error. And the keyword arguments, while the named arguments have to come first, like this actually needs a name. But the order of the keyword arguments doesn't matter. You know, I have message defined first and weather defined second, but since we have keywords, I can do weather and message and it's all good. And star args gives us an unlimited number of named arguments. Again, you want to use this with extreme caution. And star quargs gives us an unlimited number of positional arguments or keyword arguments, right? Which again, you want to use with extreme caution. And let's comment this out, and then we will dive into if then else statements and conditional logic. So conditional logic. This is pretty similar to JavaScript. So there's not too much ground to cover here. To build a good example, we could write a function to check if someone is of legal drinking age. And we might care about their age and what country they live in. Since different countries have different ages. And let's just build out a couple if else statements to see what this looks like. So if this person is greater than or equal to 21 years of age, or if they're at least 18 years old and live in a country where the legal drinking age is lower than 21, like say Canada, then, and let me go ahead and add in the 18 that I missed to get that red squiggly to go away. Then they're able to drink. But else, if maybe they live in Antarctica, which has no legal drinking age, so it's always legal for someone to drink beer in Antarctica. Otherwise, they're not of legal drinking age. And while this logic, this algorithm, does not solve every real world scenario, right? But it does help demonstrate if else statements and conditional logic in Python. And we can see or and just how friendly and readable Python can be as opposed to say JavaScript. And let's run a little bit of this code and see what it looks like. So let's try this out for someone who's 20 in the USA, and this should return false. Right, so let's make sure that our logic makes sense. And it looks like we've done something wrong here because this is returning true. So let's see where we went wrong. And I think the answer is in this else statement here. And I made the best kind of mistake, which is the kind that's easy to fix. This should probably be false, right? If you meet all these rules and you're of drinking age in the US or Canada, we want true. Antarctica, it's always true, but otherwise, you're not quite old enough yet to have a beer. So that should be false. And now, with luck, we'll see this return false. And indeed we do, right? And so that's a great example of like, it's not quite a silent error, but it's a logic error, right? Or programmer error, which is what happens all the time. And really our job as programmers is to learn a workflow that makes it easy for us to debug ourselves because we're always going to make mistakes. And really good software engineers learn to build workflows that make it easy to catch mistakes soon rather than later, right? If like I had written like 100 more lines of code and then ran it and then ran into an error, trying to figure out where this problem was would be hard. But I only have like 5 lines of code. It's easy. So we're sort of writing some informal tests here. Let's go ahead. Let's add a couple others. Right now that this person is 21, if age is greater than or equal to 21, this should return true. And indeed, we see it's now returning true. Why don't we have someone in Canada? And this should return true. And finally, let's test our Antarctica scenario. And this should return true as well, right? But instead, it's returned false. Something has gone wrong. I see a couple hands to that effect. And indeed, the challenge here is my Antarctica is all lowercase. Wow. And here it's uppercase. So how do we solve this? There's a couple ways to do this. In fact, maybe, this should be lowercase here. But then what if, this is, what if it's all caps? We would run into the same problem, right? So the answer is Python has a method that you can call on any string, which is lower, and it converts that string to lowercase. And now we should be able to make this comparison safely, and this should return true. And indeed it does. Right. And if I'm doing this a lot, maybe I even want to reset the value of country just to be country.lower, because maybe my logic is going to get more complex. And rather than having to type country.lower in like 10 different places, if we just do that right off the bat, we're going to make our life a lot easier. That's right. So now that first make it work and then make it right and then make it fast. So now that I made it work, I did a little bit of refactoring to make it easier to work with. I do see a couple questions. I do want to hold on questions for now to make sure we cover for loops and while loops, and then we'll circle back. So thank you. And give me one moment here, folks, just to organize my notes. And also I see there's a couple chat messages. All right, let's talk about looping. There are a lot of different ways to loop in Python, and it is amazing. I think it is one of the best parts of the language. And let's say we have a list of foods. You know, we're going to have pizza, we're going to have pasta, we're going to build out a nice list of meal items that we can loop over and play with. Well, there's a number of ways I can loop through things. I can do a for in loop. I don't need a counter or anything like that. I can just say for F for food, or for my food, or for food item if we want. We can loop through and print it, which is great, right? Now, what if I do need, for some reason, a counter and to do some ordering of things? Well, Python works a little bit differently. If I want to say just print numbers 1 through 10, I have to use something that Python calls a range. And a range is what Python calls an iterable. It's a special kind of object. And as it says here, while there's a little bit of density, it produces a sequence of integers from a starting point to an ending point. So just like with list slicing, there's a lot of ways to build ranges. I'm not going to go too deep into it, but I'll show maybe like 1 or 2 examples. You can have it not just count 0, 1, 2, 3, but you could also have it maybe like go 1, 3, 5, 7, 9, and so on. So this will construct that list of integers of 1 through 10. Right. And if we look at the arguments for range, we see there's a couple interesting things. If we hover over it and we can check here, we have when to start. If we only have one argument, it's when to stop, right? And we stopped, it went 0 through 9 and went up until, but not including 10. We could start at a point and we could also add a step. So I could also do for X in range, and let's start maybe at 5 and go to 15, and we'll print X. And we see it includes 5 and goes up to 14. And finally, maybe if I want to get like all the odd numbers from 1 to 20, I could do something like this. We're going to start at 1. We're going to stop really at including 20. And our interval is going to be 2. So I believe this should give us 1, 3, 5, and so on, right? Because we're seeing every 2 integers in this range or in this list that it's constructed. And indeed, we got 1, 3, 5, 7, 9, and so on. Right. So range is super powerful. If we realize that I need to go through a list and I also want an index value, I do need to use a special function called enumerate. And it would look something like this. And I'm going to use IDX, which is short for index, and we'll use food item again. And I need to call enumerate and pass it the list. And let's print an F string, and we'll say index IDX, food item, food item. I will look at enumerate a bit more in just a second. And here we see we've built an index and we have our food item. And so this is where Python is a little different. We need to use enumerate to construct what it calls an enumerate object that has an index, right? And it's really like returning tuples where the first value is the index and the second value is the item from the list. So this is for looping through a list with an index. Let's talk about now working with dictionaries. And this is where it does start to get interesting. And let's go ahead and build out. Let's actually go and grab our object that we made before, the my car object. And I'm going to put it here again, just so we can see it as a reference. And let's loop through the keys. And this one's pretty easy. For key in my car. And let's just pleat the key and we should see all of our dictionary keys. If we want to loop through the values, we can use the dot values method. And now we'll see all the values of those top level keys. And indeed we see, forward focus, right? This is the key, but we're getting just the values. If we want both, and I think someone was asking about this before, we can use dot items to get both. And that looks something like this. And this is a little bit of destructuring because we're sort of getting a tuple, and you'll see what I mean in just a sec. So dict.items is basically giving us probably a list of tuples with a key and a value, and we're destructuring it into a key and a value right here. And it looks like I have a typo, and that's because this should not be dict.items. I need the actual dictionary variable itself, my car. All right, so sometimes the error messages don't tell you what's wrong because the error is so out there. But it did tell me what line the error was on, and I did see dict was here in red, and I immediately realized that's sort of a special keyword, and I want the name of the my car variable there. And then we've got our keys and values. So those are sort of like the major looping scenarios. These are going to kind of be your bread and butter. Out of all of them, I think one to remember is this enumerate one. It's easy to forget. And you want to use it surprisingly often where you want some sort of index value along with the item in your list. So I would just sort of mentally flag this, and maybe if you have a notes or a scratch file where you keep like code tidbits to reference as you work on code, add this one to there. Let's also talk about while loops. While loops should always be used with caution because it's easier to end up in an infinite loop, but they are good for things like user input. So we're going to briefly look at while loops, but we're not going to go too deep into it. Again, just to construct a simple example here. Let's count down. right? So we're gonna have X start at 9, we're gonna decrement until we get to 0. Now, again, the reason to be careful with while loops is it's easy to screw up the logic and end up in an infinite loop. I think it's much harder to do it, especially in Python, with for loops. Really, the main reason to use a while loop is maybe for the main loop of a program dealing with user input, like a command line program. We've covered a lot of ground here, and I think we're at a good stopping point before we get into a couple more advanced things, right? We've covered conditional flow, we've covered loops, we've covered enumeration. I just want to show a couple of Python's built-in functions for things that we didn't have a chance to look at earlier, mainly with lists. So these are some handy built-in functions. I might have a name and I want to capitalize the first letter of that name. And Python has a whole bunch of great built-in functions for working. And if we hop over here, let's in fact look at some Python docs real quick. I think W3 schools can be a good reference. There is official Python documentation, which I do want to show us briefly. I do think for Python, Geeks for Geeks is a really good place to go as your sort of Python guide. The official Python documentation is incredibly comprehensive, but can be a bit dense and challenging to read. And then another great site is Real Python. And this is a really high quality site that has tons of stuff. Now, it is a lot of the content is paid, but they have a whole lot of free content. And well, unfortunately, searching for it in here doesn't seem to be so successful. If we maybe search for like Real Python, capitalize, Google can probably help take us to a good resource. And so this, I think, is really the right place to start in terms of Python resources and documentation. It's a nice sweet spot between Geeks for Geeks and the official docs. As you can see, it goes way in depth, and they've just put a lot of time and effort into this. So again, Real Python, Geeks for Geeks, the official Python documentation is probably a little too dense, but it's good to know that it's there. And those, I think, are sort of the key resources. Another string method. Oh, one moment, folks. I'm cutting. Oh, yeah. Is it the mic? I have no idea. No, I got you. All right, let me. All right, give me just one moment, folks. I'm having a bit of an.
It's like your
Okay,
internet,
hopefully it's resolved.
it's like your internet connection's like real choppy, like your audio and video are kind of coming in and out.
Okay. Thank you for the heads up there. We're just gonna push on. Hopefully it will resolve itself. We're almost at a good stopping point here to wrap up. So thank you for the heads up on that. And I'll just kind of move through these pretty quickly. Another string method here is for replacing strings. I want to find a value and replace it with something else. And my apologies, I think we may need to modify this just a touch. Yes, because replace actually returns a copy and does not modify the original. So that was the error that we ran into there. I thought this was modifying the name variable in place, but it's returning a copy. And let's see if this works now. And indeed, if we look down here, we see n is replaced. And I think the last one I want to show is for finding items in a list or dictionary, because these are extremely useful. And then we'll pause here. So let me go up a bit here to where we have our dictionary. And let's see how to find some items in a dictionary. And as you can see, it's extremely easy. And let's, in fact, go ahead and run this code. And if we want to work with the keys of this dictionary, in fact, we have a really useful method here. Dot keys will return a list of all the keys. On the other hand, if we want to work with all of the values, there's also a dot values method. And this will return a list of all of the values. And we can use this same if-in syntax to see if an item is in a list. So I could also do if 2012 is in my car.values. Right. And so this if-in syntax is really valuable both for dictionaries and lists. So I wanted to make sure that we cover that as well. And it's pretty intuitive and you'll get comfortable with it very fast. And again, just points out, I think, what a great language Python is. So we've covered a lot of ground here. To kind of recap, we've gone all the way from the fundamentals of creating variables through strings, numbers, floats, and booleans. We dove pretty deep into lists, tuples, and dictionaries. We dove really deep into functions, including star quargs and star args, some conditional flow. And then we saw just how great and easy looping is in Python. So this is a good stopping point, I think. And then when we pick up, we will be looking at some more advanced Python features. And then following that, we'll dive into testing in Python. So thank you very much. And let's go ahead and pause the recording.